Hello everyone. Today I will be presenting an experiment that reverses the common process of oxidation we see in everyday objects. We will specifically be looking at how to remove oxidation from pennies and delve into the chemistry behind it. Many objects around us are constantly undergoing oxidation over time. The purpose of today's experiment is to reverse this oxidation process on pennies using a chemical reaction. For this experiment, we will need oxidized pennies, and vinegar and water. Just this one is pure water, and salt and little bowls and timer. First, mix 1 cup of vinegar with 1 teaspoon of salt. One cup of vinegar, and then 1 teaspoon of salt. Then place the oxidized pennies. In the solution and wait for about 5 minutes. After this time, remove the pennies, rinse them with water, and dry them with a paper towel. As a control experiment, we will also immerse pennies in just water without vinegar and salt. This comparison will help us clearly see the effect of vinegar and salt. I'm gonna pour the pure water. And then I'm gonna make a timer 5 minutes. This phenomenon occurs through the oxidation and reduction reaction. The acetic acid in vinegar react with the penny's oxide to restore the copper, while the salt increases the conductivity of the solution. Speeding up the reaction, the products of this reaction include copper acetate, water, and a small amount of hydrogen gas. Through today's experiment, we explored a simple yet fascinating chemical reaction using everyday materials to restore oxidized metals. It reminds us of how closely science is linked to our daily lives. So I'm gonna wait 5 minutes. During the time, I'm gonna show you my presentation, more detailed information. So I finished the 5 minutes. So we can check our result, right? So I want to check this penny in the vinegar and salt solution. Let's see. I'm gonna wipe the water. Okay. Okay, it is very clean, right? And then I'm gonna check other comfort experiment, complement experiment. It is same. It is too dirty, still dirty, right? So that's it. Thank you. Okay, I'm gonna add the penny oxidation experiment. So I finished that 5 minutes already. And then this water inside these pennies is same thing. No change, nothing. But this penny inside of vinegar and salt. Let's see. Oh. It is very clean. So the goal of this experiment is to demonstrate the chemical process of reducing oxidation of pennies using vinegar and salt. This not only helps in understanding the chemical reaction involved, but also the practical application of chemistry in preserving materials. So we need the pennies, vinegar, for acetic acid, and salt for sodium chloride, and water, small bowls, and paper towels. Vinegar acts as an acid to dissolve the copper oxide, while salt boosts the conductivity of the solution, making the reaction more efficient. So this experimental procedure, we already follow that. There's a step-by-step guide, right? Mix 1 cup of vinegar with a teaspoon of salt in a beaker. Place the oxidized pennies in the solution. Wait for 5 minutes and observe the change. Remove the pennies and rinse them underwater, then dry with paper towels. After that, we need to figure out about the counter experiment. As a counter, we also submerge pennies in plain water to compare the effect. So the process of removing oxidation from pennies involves a chemical reaction known as a redox reaction. Reduction oxidation, same meaning. In this reaction, the vinegar acetic acid reduces the copper oxide, the same meaning is the rust, on the penny, restoring it to a metallic copper while itself becoming oxidized. So we can check this reaction formula. Copper oxide plus acetic acid, it makes the CuCH3COOH, COO2, copper acetate, add water. The acetic acid in vinegar reacts with the copper oxide on the pennies to form copper acetate, which is soluble in water, thus cleaning the penny. Salt or sodium chloride act as a catalyst, speeding up the reaction. So salt is added to the vinegar solution to serve as an electrolyte, which helps in increasing the solution's conductivity. This accelerates the reduction reaction. And then copper acetate, this occurs as the acetic acid reacts with the copper oxide on the pennies, and the water formed as byproduct of the reaction. And then sodium acetate formed when the sodium chloride reacts with the acetic acid through its formation is secondary and not the primary focus of this experiment. Lastly, hydrogen gas may also be released very minimally as a byproduct in some cases. We can measure this experiment not only demonstrates a simple chemical reaction, but also highlights the importance of chemistry in everyday life, from preserving metals to understanding cohesion.